Today in this video, we are going to discuss about the wave function psi. Matter waves are not real waves and therefore cannot be represented by wave displacement. In electromagnetic wave, electric and magnetic field vary periodically. In sound wave, pressure varies periodically. In water wave, height of water varies periodically. Similarly, the quantity which varies in case of matter wave is the wave function psi. In classical physics, wave function of classical waves like mechanical waves or electromagnetic waves contain all the information about amplitude, speed and wavelength, etc. Similarly, wave function of matter wave contains all the information required for the probabilistic description of a quantum mechanical system. However, unlike wave function of classical waves, wave function psi of matter wave has no direct physical significance. Whereas the square of the absolute value of the wave function mod psi square is known as the probability density, which has direct physical significance. Let us now see what are the characteristics of wave functions of matter wave. The first one, we said wave functions are the mathematical representation of particles which contain all the information required for the probabilistic description of the particles. The wave function psi is a mathematical function of space and time. That is, psi, you can see, is a function of x, y, z, the space coordinates, and t is the time. The wave function psi is a complex function, and psi multiplied with its conjugate gives mod psi square, which is known as the probability density and is real. The wave function psi must be continuous and single valued everywhere, so as the partial differentiation of the wave function psi with respect to x, y, and z must be continuous and single valued everywhere. Limit x tends to plus minus infinity psi equals 0. Similarly, limit y tends to plus minus infinity over the wave function psi is 0, and limit z tends to plus minus infinity over psi is 0. So any of the space coordinate, if is extended to plus infinity or minus infinity, then the wave function is not well defined. Integration over minus infinite to plus infinite mod psi square dv is a finite quantity. The wave function psi must satisfy Schrodinger's equation, which we will discuss in some other video. The quantity mod psi square represents the probability density or the probability per unit volume of finding the system in the state. So the wave function psi is regarded as the probability amplitude. For the particle described by the wave function psi, if mod psi square dv integrated over the volume is 0, then the particle is not present in the specified volume. And if mod psi square dv over the volume is equal to 1, then the particle is present in the specified volume.